Okay guys, so we're going to go over our next part of our motion standard, and that's dealing with Newton's 3 laws of motion, as well as balanced and unbalanced forces. Okay, so take a minute and see if you can identify the terms here and their correct definitions. Okay, so here's our answers. Number 1, the force that slows things down, that is friction. Friction when things are rubbing past each other, that's what's slowing things down. Number 2, an acceleration that pulls all matter together, that's gravity. Gravity's pulling everything together. Number 3, what makes an object hard to move? This is inertia. 4, what makes an object hard to stop? Again, inertia. Number 5, when there are 2 forces equal in magnitude but in opposite direction, this is a balanced force. And number 6, when there are 2 forces that are unequal in magnitude in the same or in different directions, it is unbalanced. So unequal is unbalanced, equal is balanced. Okay, so looking at these 2 pictures, try to identify which one is going to be balanced and which one is unbalanced. So this first one is a balanced force. We have the same number of newtons, the same amount of force being applied in either direction. And notice that when we have this balanced force, it's not going to move. If we have this happening in this tug of war, neither side is winning. They're tied. In this second one, it's unbalanced. That means it's going to cause motion to happen. And in this case, the motion is going to move to the left. These are the people applying more force. Therefore, their winning is going to move towards them. Okay, so look at this first example where we have 75 newtons and 125 newtons. What is the net force? Okay, so in this example, our net force is going to be 50 newtons to the left. So we can look at this because these are going in opposite directions, so we're going to subtract them. So we can think about doing 125 newtons from over here minus the 75 newtons from this side equals our 50 newtons. Or you can think about it that if this one has 75 and this one has 125, the one over here in yellow, he's going to win, and he wins by 50 newtons. So 50 newtons is our net force, and it's going to the left because that's the direction of his force. Then look at this example with the movers and try to figure out what the net force is. In this example, it's going to be 45 newtons to the right. So notice this time, both of them are going in the same direction. So we're not going to subtract. Their forces are being added together so that they are both going in the same direction. So we take our 25 newtons plus the 20 newtons of the other person to give us the 45. That's because these are going in the same direction, and therefore they're going to the right. So that's how we get our net force. Okay, so now we're dealing with the resistance to a change in motion, and this is inertia. So remember, an object at rest wants to stay at rest, and an object in motion wants to stay in motion. This is the idea of inertia. It's resisting a change to move. It's not wanting to move. It's not wanting to change its movement. It's not wanting, if it's stopped, it's not wanting to move. If it's moving, it doesn't want to stop. This is inertia. So in this case of our skateboard and the glass test tube, it is moving and it wants to stay moving. So even though the skateboard gets stuck by the rock, the glass is going to continue to move until it falls over. And then here with this example, an object at rest stays at rest until acted upon by another object. So in this case, they're staying at rest until they act upon by gravity, pulling them down the ramp. Okay, so you might remember this example in class. So this again shows Newton's first law of motion, inertia. The man is in motion because he's on the train, and his inertia wants him to keep moving. So therefore, when his feet hit the ground, they stop because of friction. but his body stays in motion and that makes him fall over. In this example, we have a bowling ball and a balloon that are both being hit with the same amount of force. You might notice that the bowling ball barely moves while the balloon moves a whole lot. This is because still of inertia. The bowling ball is resisting the change to move, and the balloon is as well, but the bowling ball is resisting more because it has a larger mass. And this relates also to our second law of motion, which is force equals mass times acceleration, which is telling us that if we have a larger mass, like the bowling ball, it's going to take a larger force to move that bowling ball. Or you could think about it that if we have a larger mass, it is going to accelerate less than the bowling ball, or than the balloon does. So the one with the smaller mass has more acceleration. The one with the larger mass has less acceleration. Okay, we can also demonstrate Newton's third law now by hitting our table. So if you do that, you're applying a force onto the table, but the table is also applying a force back onto your hand, and that's why your hand will hurt if you hit the table too hard. Okay, so our last part of the standard is really related to our other one. It's about inertia, which we've kind of already covered. An object's natural resistance to a change of motion is inertia. It's based on the object's mass. So therefore, the more mass, the more inertia. So that's what we were talking about. Larger the mass, just like that bowling ball had more mass than the balloon. So therefore, the bowling ball is going to resist that change to move even more so.